Good afternoon and welcome back to the workbench. So today I'm enacting an idea I had, which I thought I'd try out just for fun and amusement, which was to buy some random, mysteriously faulty item of electronic trickery and just try and make a video out of it and try and repair it and just see what happens. So the item in question, as the title suggests, is a inverter, 12 volt to 240 volt, obviously for your car, etc. boat, whatever, and it should be in this box here. Now, I say it should be because I don't know, I haven't opened it yet, and there was a little bit of hassle and issue with the actual transaction of getting it, so I don't know what's in here. It could in fact be a box of rats or something else, I'm not sure. I don't know, probably, hopefully not, but we'll find out. So yeah, it was just listed literally as $1 reserve auction, faulty, no description practically at all whatsoever. 1000 watt inverter, or 2000 watt, I can't even remember now, it took so long to get it. But yeah, basically standard cheap inverter, apparently it doesn't work, don't know really why, don't know what's wrong with it. We'll find out, that's the fun, that's the point. So let's open it and just see what we've got. See if this is actually a broken inverter. I don't know. So, let's have a look. It seems to be packaged fairly well, at least, so there's that. It's packaged annoyingly well. Alright. Let's see. The other end, of course. There we go. Alright, so we have some polystyrene. It's a good start. Well, at least that proves it was packed well, whatever it is. Sheet of polystyrene. Another sheet of polystyrene. Another bit of broken sheet. There we go, look at that. Power inverter, it looks about right. Let's see. Let me bring this out like this, maybe. There we go. Alright. Yep, that looks like an inverter. Let me just get this box out of the way. Alright, well, there you go. Power inverter, 2000 watts, apparently. Safely shuts down on over temperature, 12 volts to AC, DC 12 volts to 220 volts AC. Safely shuts down on overload condition. Apparently you can use it for a TV, a computer, a VCD/DVD, which shows a picture of a stereo system. That makes sense. Fax machine. A fax machine. You can run your fax machine off this in your car, because you're going to be faxing over... what? Yeah. Faxing over your mobile network. I don't know. Someone might be doing it. You can... Fifth icon shows apparently what is a hammer and shows a picture of a electric drill. Right. You can also run an electricity tea cooker. Well, this is just great. I mean, the label is amusement in itself. I mean, yeah, it's just brilliant. Power inverter, USB, 2000 watt. 2000 watt USB port? What? Fully automatic DC to AC inverter, safely shuts down if over temperature or overload condition. And it can drive your electricity tea cooker. Well, I'm glad. I'm glad it can do that. I don't think it would be able to do that because my electricity tea cooker is in fact about 2400 watts, so it would probably shut down on overload. But anyway, the back of this has got a switch. It's got a power socket as you'd expect, it's got a USB port as well, and the thing says out 230 volts. So already it's conflicted on its ratings. It's got big fat 12 volt inputs there, and a fan. And a nice aluminium case, bunch of screws on the side, it's probably a bunch of MOSFETs or something, and more screws on this side, so yeah, I don't know, looks alright. shall we open it and see what's in it? First thing I'm going to do is smell it. Does not smell too bad. It smells like polystyrene and sellotape more than anything else, but there's no obvious sign of no obvious smell of exploded MOSFET or anything, so that's a good start, I guess. Now, I'm going to use common sense here, try and figure this out. So the label does have a bit of damage. The thing is a little bit scraped up. Not very much, but I mean it does look like it's had use. The person selling these was also selling apparently new ones that were fully working, so I just wondered if maybe it was just like a DOA unit from the factory or something, but it looks like this may have been used at some point, so possibly it was used until it broke and then he just sold it for nothing. Yeah, so I don't know, it could be an actual failure rather than some sort of assembly error or anything like that. Doesn't look like it's had much use though, if it has had any. It's pretty clean. Yeah, well anyway, let's open it up and see what's inside. But like I said, I can't smell anything exploded, so that's probably a good start anyway. Maybe it's just who knows? Maybe a wire has fallen off. You never know. Tell you what I'm going to do, just for fun, is get my multimeter. Where have I put that? Oh well, I'll get another one. Get this one. Let's just test across the inputs and see if there's a short circuit or something like that. That would be an interesting thing to try. Possibly. Hopefully you can see that. So, got our input things. Let's take that off. Be easier. Let's see. Dead short across the input. That's interesting. That's probably not supposed to be like that. I don't know. I mean, I've never actually owned an inverter before. Let's try it switched. Let's try switch the switch. See if it makes any difference. I'm going to guess it's not supposed to do that. Probably shouldn't be a dead short directly across the input. So there we go. That probably explains a lot. Who knows? Could be anything. Reverse protection diode that's blown up. Could be blown MOSFETs. Could be yeah, I mean anything. Could be a I don't know. No idea. But there we go. That's that tells us what we're dealing with. Something is shorted in here, and that's probably the fault. What? I don't know. Let's have a look and open it up. Oh wait, the case comes in half from the top. Oh, that's good. I thought it was just a whole solid extrusion thing that starting to wonder if I should get an electric screwdriver. Oh, I've actually got an electric screwdriver. It's this one here, except it's rather slow. It's not particularly useful for high-speed work. And hardly ever use it. In fact, I usually use it as a drill, if anything. Just a low-speed manual sort of drill for doing basic things. But yeah, the electricity tea cooker. I've never heard of that name before for an electric kettle. Well, let's see. Guess you can't really see this. Unless I take the top off. That would be a smart thing to do, wouldn't it? So, yep, we've got a lot of TO220 packages in there, and also some TO, what is it, 256? I'm not sure. Wow, this thing looks pretty cheap and nasty, I must admit. So we got 4 transformers there, looks like. Oh, there we go. I can see the damage already. Some of these FETs, or whatever they are, have definitely blown up. This one has exploded. So that's interesting. There goes my theory of smelling it to see if anything was exploded. I can't even smell that as it is now. It must have been sitting around for so long. It's, the smell is all gone. But yeah, something's definitely gone bang there. Yeah, I got one with a crack in it here. This one's definitely exploded. There's a huge crack in it. This one's got a little hole. This one's got a crack. Probably all of these have blown. Not sure how this works. Got the symbol on these 4 parts, like back-to-back diode pairs. I don't know what that's for. Maybe that's the output for the, something to do with the output for the USB supply. I mean, you're obviously not going to be rectifying the AC, because it's AC. We've got a pile of parallel 40 amp fuses, it looks like. Wow. How many? 7. 7 40 amp fuses stuck in parallel. Something tells me that's a bit overkill. But anyway, have any of them blown? It does not look like it. Which is not really surprising, I suppose. Yes, well anyway. Is this thing worth repairing? That is the question, I guess. I mean, it looks like all the FETs or whatever down this side are probably all blown. I mean, I can definitely see at least 5 of them are blown, so most likely those are just the bad ones. The rest are probably all shorted anyway. Trying to figure out how this thing works. We've got a little board there. Could be a control circuit. What's that? It's KA7500BS. Well, I don't know what that is, but I guess it's some sort of like purpose-built inverter controller or PWM controller or something. These parts aren't marked as anything specific. Like I said, 4 diodes there. V2A, V2A1. There's some surface mount fuses that look pretty cooked. QD. Got some like surface mount diodes and transistors or something around the place. But all these TO220s, the ones that have blown up, they seem to be marked as V. So I don't know. It kind of makes no sense to me. Unless I'm looking at the wrong thing. It is kind of next to some kind of thing here. Looks like some via stitching, so maybe the V is the via stitching or something, but I can't see any ref dirs for the actual parts unless it's on the other side of the board or something. There's a thermistor on the end there, which at least is nicely the opposite end from the fan, so at least it's going to give you an accurate, or at least it's going to show you the worst temperature in the unit. Oh, there's some more parts down here. Another KA 5000. And then we got a
324, what's that, a LM324 comparator or something, op amp. Yeah, so I have no idea what the topology for these kind of things is. I mean, obviously they've got 4 sections in parallel. So I guess it's, and we've got 4, well, we've got 2, 4, 6, 8, 10, 12, 14, 16. So we got, yeah, you got 4 of these devices per transformer. So maybe it's might be like a push-pull thing or something, or a full bridge, full H bridge. I'm not sure to drive it. That would, I suppose, be the most efficient if it was a full H bridge. As to why it's exploded, I have no idea. It could be that the I mean, there doesn't, well, there are some pretty large diodes in here next to these capacitors, which might be for reverse polarity protection. There's nothing obvious for that though, so possibly it was wired in backwards and these just blew from reverse polarity. Maybe the controller went bad and, you know, the dead time didn't work anymore. If you, you know, H bridges circuits, if you do those incorrectly, you can short out both sides and then everything will blow up. So could be the controller just went mad. I don't know what this stuff down here is for. It's kind of strange. I mean, we've got, if these are like some sort of control thing driving the primary, these are obviously rectifiers, and we've got this thing here, and this seems to be feeding the something to do with the USB and maybe the some of this output monitoring circuitry or something. But what these are for, I don't know. And there's no, again, we got this V designator here. Although one of these AC wires is connected directly to one of these, so I don't know. Maybe it's maybe they modulate. I mean, is this thing? I mean, it doesn't claim to be sine wave or anything. It doesn't even claim to be modified sine wave. So it's probably like some kind of horrible stepped square wave thing, as they usually do with cheap stuff. So maybe each of these, I don't know, maybe each of these outputs a different voltage level, and then they're switched by these MOSFETs here. Maybe these ones are acting as switches. You got maybe like your negative, you know, like negative 220 volts, negative 110, and then it goes to 0 and then all off. Then you get positive 110, then positive 220. So you get like a sort of a 2-step square wave. That sort of seems to be a common thing with cheap inverters and UPSs and stuff like this. So maybe that's what they're doing. I mean, I can't really see. Obviously they're not rectifiers. It wouldn't make any sense because it wants to have AC, but unless it is square wave, you wouldn't need that. I don't know. Like I said, I have no idea how these things work. I've just seen random things on the internet and I'm just guessing. So I'll do my research later on and find out something about it. I can look this thing up. We can see if there's anything obvious. Trying to see if there's an obvious model number, because these things are probably pretty generic. There's a date code, it's 2011 September 20th. So I guess this thing's at least that old, which would make it about 8 years. I mean, well, the design is at least 8 years old. Don't know if this actual particular thing is. Oh no. Those aren't actually fuses, those are possibly gate resistors, which have incinerated themselves. Fortunately, not all of them have incinerated themselves, so I can at least get the things if I was actually going to fix this. I don't know. I mean, depending on what the parts are, it might be fairly cheap to get something. Who knows? We've got an FB 200V02. That might be the generic model number for this. I don't know. And then again, down here, FB200V04. Doesn't seem to be able to decide what version number it is. Well, anyway, yeah, I think it's time to do some research and start trying to figure out exactly how this thing works, what sort of topology it is, and what may likely have gone wrong. Yeah, and then I guess I got to undo all these screws and pull out some of these little clamping bracket things and have a look at what part numbers these are and see how much it would cost to buy new ones, because that will be really the deciding factor of whether I actually bother to fix this or not. If it is, for example, like $50 to buy all these MOSFETs or whatever they are, well, that's kind of pointless. So yeah, it wouldn't really be worth it. I could buy a whole new one of these that was actually working for less than that, so you know. But hey, maybe we could buy some cheap replacements from eBay or something and just see what that does. I don't know. I'm going to go online here and look up some of these model numbers and see if I can get any information from it. MT3205. MT3205. That doesn't sound like anything I've heard of before. MT3205. MT does not sound like a standard prefix. 3205. Mus tool. N-channel power trench. Okay. MOSTEC Semiconductor Co. Looks like some Chinese thing. And yet the datasheet looks suspiciously similar to OnSemi. The website is MT Semi. Interesting. Some kind of like official second source supplier, or is it just a complete rip-off? MOSTEC. I'm not making any obvious references to any other company, but datasheet's pretty professional, actually, compared to a lot of the Chinese datasheets you get that have like no information whatsoever. So this one's actually pretty good. So yeah, standard like N-channel MOSFET, 55 volts, 110 amps, TO220. Yeah, claims a pulsed drain current of 390 amps. That's pretty impressive if it's true. Yeah, MT3025. I wonder how much those would cost. I'm going to guess you can't buy them at... There's even a power supply called the Mus Tool MT3205. Interesting. Anyway, IRF 3205. Ah, there we go. Is that what it is? Is it just a copy of this? Yep, the 390 amp pulse current, 110 continuous. 55 volts, 8 milliohm IDS on. Yeah, these are very, very similar. So this is literally probably just a copy of this. That makes sense. Can you buy them? How much do they cost? Let's go on eBay. Actually, let's go to UT Source, because they're probably more trustworthy. I don't know if I want to buy MOSFETs from eBay. It's probably not a good idea. Let's have a look at let's have a look at Farnell as well. Let's see. IRF 3205, $2, $250, $260. Okay. It's the lowest price. MT3205. 70 cents US on UT Source. That's a bit better price, isn't it? Whereas we can buy the genuine IRF part for as little as $36, $86.
No, wait, that's out of stock. How much would 16 of these cost? That's the question, right? $36. Yeah. Is it worth it? I don't know. How much to buy it from here? Well, if we bought 36 of them, 16, sorry. $16 of them from UT Source would be $11.70 US. That is definitely a lot better. So that's going to be like, I don't know, $20 New Zealand, I think, or so. Maybe less, maybe like 18. That's about half the price of buying the genuine IRF ones. Yeah, maybe worth that. I don't know. Let's see. MT3205. Can we get that? Can we get the genuine ones? How much would they cost? The genuine ones. Whoops. Let's search for IRF 3205. It's even cheaper. 40 cents. 70 cents. Yeah. And we 60 cents, 60 cents, 70 cents, 80 cents, 60, 90. There's a lot of them here. Those are all surface mount versions. There we go. IRF 5205, 42 cents. Quantity even less, 35 cents and over 10. So yeah, it's got positive 5-star rating, 99.3%. That's pretty good. Date code 2002. What if I wanted to buy like 20 of those? Because you probably want some spare. Yeah, I mean that's $7.94, $8 US for 20 IRF 3205s. Probably not genuine whatsoever, but hey. Yeah, I mean, is it worth it? They're probably no worse than the MT3205s, although those do cost a little bit more. Who knows? Anyway, certainly not too expensive to give it a go, and if I did get it working, it would be potentially useful. I could stick it in my car and use it as an inverter, I suppose, or something. Yeah, what was the KA 7500? What is that? SMPS controller. Oh yeah, so it's just a basic PWM controller for switching power supplies. Obviously, this is yeah, so there we go, basic thing there. So, you know, once we know how this works, we can check out the control circuit and see if it's actually producing the right drive signals and that kind of thing. I'll do some more diagnosis on this and see if we can find out why all these FETs actually blew up. I mean, you know, could be several reasons, but yeah, gotta figure that out first, because until you find out why they blew up, there's no point in just replacing them blindly and hoping it'll work, because if there is some driver fault or controller fault, they will just blow up again. So you want to check to make sure there's nothing funny like that going on. I mean, if they just overheated or something and then blew up, then, you know, that's more understandable, but I mean, these four circuits might all be in parallel, controlled by this one controller, in which case, you know, I mean, one of these blows, it might have blown the whole thing. The gate drive circuit's probably all blown, possibly. And then again, maybe not. I mean, this only takes 12 volt input, not like an actual computer power supply where it's got a 300 volt input or so. So maybe the gate drive is fine, but you never know. All depends how the thing blew up. So yeah. Okay, so I'm just going to have a more close-up look at this, and I'll describe what I've discovered just having a look at it. So, we got basically, it's in sort of two stages, it's two sets of power supplies in a way. We got these 4 transformers, these are driven each one by 4 of these MOSFETs. We've got 2 filter caps on the input of each one, and they're all driven from the same KA7500, which is down here, and it's also got the feedback circuitry comparator or whatever it was down there. Some little gate drive components there, you can just see under this fan wire. These 4 transistors here, these are probably bipolar ones, I'm guessing. I haven't actually looked up the numbers yet, but these seem to be driven by the KA7500, and then these drive all the gates for these. So basically everything's just run in parallel. It's probably identical drive signal, which maybe isn't the best way of doing it. There doesn't seem to be any like feedback for each individual circuit, it's just like for the final output. So this basically boosted up to about 300 volts DC. This is I think a push-pull configuration. You've got like a center tapped winding, or I think there's actually 2 primary windings, and they're put in series with a center connection. If you look on the back, you can see how that works. But we basically got each pair, we got like a center connection there with these 2 pins here, and then these other pins there go to the MOSFET. So this connects to the 12 volt input, and then each of these sides is pulled down to ground through 2 pairs of parallel MOSFETs. Well, in total, each side is pulled with 1 pair of parallel MOSFETs, I should say, but you got 4 in total for each one, 2 MOSFETs for each winding. Anyway. So it all seems quite simple really, in terms of that, but it looks like, the 4 MOSFETs here, these ones are definitely this one's totally exploded, these ones are all popped, and then the 4 over here, these 4 there are also all done. The 8 in the middle actually still look okay, and the gate resistors and that haven't burnt or anything, so quite possibly these ones are all still perfectly fine. It's just the 8 on the 2 ends that have actually blown up. So what I'm going to do is I'm going to pull the 4 here and the 4 there, and I'll remove the resistors and everything, and then I'm going to check to see if we still got a short on the input. There's also some, I think, reverse polarity input diodes. There's one here, and then they've got one in between these capacitors there, and then a 3rd one down here. So I don't know why they've only got 3, but I mean, it's all kind of a joke though, especially when you've got all these fuses here, which equate to about 240 amps of current protection. So I mean, I'm pretty sure it's a safe bet to say that the MOSFETs, the transistors, the transformers, the diodes, everything else is going to blow long before these fuses all blow. So I don't get that at all. It doesn't make any sense. Anyway, but on the output side, we've got these other MOSFETs. So it looks like I still haven't figured out exactly how this works, but we got these 4 rectifying diodes here. So they're all in parallel. They rectify the outputs of these 4 to filter into these capacitors here, and that gives you about 300 volts DC apparently, at least according to this silk screen here, which says 300 volts across those terminals. Probably is. And then it looks like we got another KA7500 over here, and that's switching, I guess it looks like these 4 here. So again, I guess it's probably switching these some kind of configuration that provides a inverting square wave, I guess, on the output. So whether or not that's stepped or not, I don't know. Probably it might not be. It might just literally be a square wave. And then these seem to be doing some sort of current sense. I'm not entirely sure how this exactly is working. Maybe these are switched on separately as well, so that the polarities match up depending on which ones of these are on. I don't know exactly. I haven't looked into it and traced it out or anything, but I'm guessing that's what it does. In any case, this all seems fine, this secondary output side, so the output looks fine, nothing's burnt there, nothing looks blowed up, so Looks like the problem basically is just these MOSFETs on the input, on the primary side. Yeah, I mean, if someone connected the battery backwards, I'd expect these diodes to have exploded, and all the MOSFETs to have gone probably. But maybe these ones just overheated or something. I mean, if the control circuit went bad, I'd expect all of them to be blown again, unless these ones just blew first and then took out a fuse or something somewhere before the rest had a chance to blow. But it's quite possible that these MOSFETs just overheated or just blew from just old age or something. Interesting that it's just the ones at the end there. I wonder if it could be like a temperature problem. Maybe the ones in the middle run cooler somehow. The fan, the airflow might be. There's just one fan here, and that just pulls it across the entire board through these vents on the other side. So maybe the ones on the end get less cooling. I don't know. I mean, it could be anything really. I'll remove all these blown up ones and see if we can get the short to go away. Actually, just looking there, it looks like there might be another set of drive transistors there as well. So I don't know. And they've got what looks like should have been like a 3-terminal regulator or a transistor or something with a heatsink, and they've just replaced it with a single resistor. That's amusing. Anyway, yeah, this thing is definitely very budget, so it's not surprising that it's pretty basic design. Interestingly, yeah, the seller that I bought this off, so I got this one for about $20 including shipping, which was probably the most expensive part of the whole deal. And he's also selling the exact same model in working condition, brand new, for $70. So yeah, it doesn't look like these things are worth that much, to be honest. So I'd really like to keep the repair below $20 if possible. There's no real logic in going any higher than that. By the looks of it though, hopefully if I'm lucky, it's just these MOSFETs have just failed sort of on their own accord, and I should just be able to replace just the 4 here and the 4 at the other end, and hopefully that should get it working again, which would be actually really cheap. And also that means that because each of these suppliers are separate, I shouldn't need to match them to the other ones. They should only really need to be matched in pairs per each side of the winding. So like these two should be matched with each other, and then these two should be matched. But these two pairs probably don't need to be matched to the other pair, and the pairs here don't need to be matched to these pairs, I don't think. So hopefully that would make sense. I mean, if they were all in parallel, you'd want to match them, but it looks like they probably only need to be matched per pair, and at worst per 4. So yeah, I can probably get away with replacing these only and just leaving these if these ones are still good. Yeah, that said, we don't know if these have been stressed or not. I mean, we don't know exactly what caused the failure, but I'm just going to guess, going by the basic cheapness of the whole unit, that these MOSFETs are probably just cheap FETs and they just blew by themselves. Just maybe got too hot or something. But yeah, the drive circuit, there's nothing blown on that that I could see. I can bring that, let's see if I can get that around here. So I mean that's just on there. Focus, yeah, there we go. Yeah, so that's a the KA7500 on the right, and then we've got there's a op-amp or comparator or something for feedback on the left, so that's obviously going to monitor the 300 volt output that goes into these filter caps. And then yeah, I guess it's then switched by these other MOSFETs down here to provide the false sine wave, or whatever it is, whether it's stepped or just a square wave, I don't know. It's probably nothing particularly fancy going by the looks of this thing, but yeah, possibly this diode here might be bad if there was a reverse polarity incident. It doesn't look bad though, and then these drive transistors here might be a bit dodgy. So possibly we may have 4 of these to drive, 8 of these FETs, and then the other 4 down here on the board there, maybe drive the other 8 or something. So I'll have to check all those out, because Yeah, I mean these MOSFETs blew up pretty well, so it's possible the drive circuitry is blown too. The good thing is that unless this controller was already bad, I would say the damage would be limited to just these FETs and then probably these drive transistors. Probably wouldn't go all the way back to the controller, so I can probably just leave that. It's probably fine. And like I said, possibly if this went bad, then I'd expect like everything to have blown, I guess. But it doesn't seem like that's the problem. So I'm just going to go on the assumption that it's just those FETs that have just gone by themselves. And I shall desolder them, and we shall see if that gets rid of the short circuit. Okay, so I've removed all the obviously blown MOSFETs. You can see them here. They're pretty bad condition. This one here is completely exploded, and most of the other ones have had their pins fallen off or cracked or whatever. Anyway, so those are all toast. Although I don't suggest you eat them. This still got some sort of scorch marks that you have to clean off, but that shouldn't matter for testing. So I got this back in diode mode, and we can see if we've still got that dead short across the input. So let's hook that up. It works. Let's see. Nope, something's still blown. So it could be any of these other MOSFETs here. It could be maybe, well, it shouldn't be any of these, but maybe it is. Could be these diodes. Who knows? Or what I suspect possibly the gate drive transistors in here might have something going funny with them. Yeah, none of these seem too bad. Not shorted anyway, that's for sure. So if I ignore those for now. Maybe it's the yeah, I'd say most likely it's just the other MOSFETs. Hang on. Maybe I've confused myself. Maybe I'm measuring the no, hang on, I mean actually I don't think I do have a dead short now. What I'm actually getting, I don't know if you can see this on the camera, what I'm actually getting is rising voltage, I think, of all these capacitors here charging. So possibly this thing is actually fine now. So maybe I've just trolled myself. I'm tempted to apply 12 volts to it with my power supply, just in current limit mode, and just see what happens. Shall I do that? I mean, it's quite tempting, isn't it? It kind of makes sense, if these are all in parallel and we just got two of them off, they shouldn't do anything and the other two should still work. So technically, if these MOSFETs are all still fine, this might actually work now, just with the other ones disconnected. I mean, these two transformers obviously won't be doing anything, but the middle two might actually be working. So let me just set my voltage to 12 volts. Actually, I don't really need to, do I? Because this thing is designed probably to work off a cart, which is going to be anywhere between like 12 and 14 volts. But hey, let's do a check on this. What do we got? Let's give it 12.22 volts. Why not? It'll do. Let's see. So I'm going to have this limited to like something, I don't know, like 200 milliamps just to start with, just to see what happens. How does this work? Got a power switch. Switch that off. Should work. For testing purposes, let's see what happens. Switch it on. Okay, it drew a bunch of current, and then it stopped. So that's probably the caps charging up. So let's just turn that off and see if we got any voltage on this output here. So we're on DC volts. Got anything? No. Well, that makes sense because we didn't actually switch it on. Aha! Interesting. Don't know what that alarm means.
But anyway, do those get warm at all? No. Okay. Let's try it again. Let's switch that on. Capacitors have charged. Doesn't seem to like that, does it? Oh, there we go. Give it some more current. The voltage is up. So maybe... Oh, there we go. It's drawing like 2 amps. I think that alarm is just the low current alarm or something. Let's see if we got any voltage out the output. Did any of those do anything? No. .9 volts. Yeah, that doesn't really make sense, does it? That should be 300 volts apparently. We got 0.9 out of it. So clearly something is still not working. Yeah, we get like 0.1 volt and the fan doesn't spin. So I'm guessing what it's probably doing is it's probably going into some kind of protection mode. The controller is either sensing that these MOSFETs aren't connected or something. Okay, well I decided just to give it a try at powering it up and checking the drive waveforms to the FETs on my oscilloscope here. So if you actually have a look, if I switch this on, it's already on. If I switch it on, we actually get a nice square wave that looks really clean and really quite nice. So yeah, and we actually don't get the fault light coming on, we only get the power light. So it's interesting, it seems to be working, although why I'm not getting any voltage on these capacitors here, I'm not sure. It seems strange, and this thing's drawing 2 amps when it switches on, and yet these aren't getting hot at all, and I can't see where the actual current is coming from, and the fan doesn't spin. Unless it's temperature controlled, I don't know. It's just kind of odd. It's like the FETs are getting their power. I mean, I can try. That's on this particular inverter section. I can try the other. I'll check the other side and see. I mean, that one looks fine. So at least this particular circuit there is okay. Let's call that number 2. That can be 1, 2, 3, 4. So we're getting power, to this one. That looks fine. So that section. So let's try number 3. I mean, that's working fine. I mean, if I get 2 probes up here, actually, we should see they should be out of phase because it's a kind of a push-pull thing. Actually, so if I test, I don't need to connect the ground clip on this one because it's already connected on here. So if I check, say, this side, so we're checking like you can't see on the camera I guess, but I'm checking, one side here and one side there. So if we put this on to both, put this on here, we should get 2 waveforms when I switch it on, and we do, and they're out of phase, which makes perfect sense. So I mean, yeah, it is seems to be working. So it's working on that this circuit number 3, and if I go over to number 2, we get the exact same thing. We get the drive waveforms. Makes sense there. So that all seems to be working. So the controller, which is this one here, KA7500, so that seems to be driving these just fine. So I guess the controller didn't fail and cause the FETs to blow up. It doesn't seem to be the issue. So why I'm not getting the 300 volts output is a mystery. And again, I mean, we're drawing 2 amps, so power is going somewhere. I don't know where. Unless it's just doing that because there's no load or something. I mean, who knows? Of course, this is where you present a problem with these probes. If I want to probe the input and the output, they should be isolated from each other. If I connect my ground clip
to the ground on that side and also the ground on this side, I'll blow it up because I'm shorting the grounds together. So we don't do that. We want to only probe one side at once with these probes. So I need to disconnect the first one here if I wanted to probe the output. So I'm clipped on the output ground to the ground, and this is not connected to anything. And then I got this onto one of the inputs of one of the rectifiers. So we should see on channel 2, if I just put channel 2 on, we should see like a 5 volts for division, 30 volts, maximum I guess, be 510, you know, should see like a waveform there or something. But we get absolutely nothing, which kind of makes sense. There is a waveform. There is some kind of waveform, but it's very low amplitude. So, yeah. I'm guessing those getting warm. Yeah, the transformers are getting kind of warm. MOSFETs are pretty cool. I think the power is just getting wasted in these two that aren't actually connected and not being driven, so it's just shorting them out. It's just acting like a... well, could be. I don't know. Okay, so I just turned over the board and now it all makes sense. I just wasn't paying attention properly the first time when I looked at it. So yeah, each of these transformers is driven by a sort of push-pull configuration of these MOSFETs, as I showed with the drive waveforms, but each of these ones here also seems to be paralleled in a way to the next one. So what we've actually got, instead of 4 separate things all in parallel, it seems to be these two operate together and then these two operate together. So I'm not sure what sort of topology this is, but the outputs of the transformers actually go in series. So this one is one end of the output winding, and that goes off down this big fat trace to the rectifier. And then the other side of the winding actually goes straight into the winding on the next transformer, and that goes through there, and then that goes out to the other side of the rectifier. So yeah, it looks like these are actually working together, so I'm not sure if they're possibly just increasing the voltage by putting them in series, I guess. I mean, it wouldn't really make sense that if they were running these in like push-pull or something. I don't think that's even possible. Basically, by not having any MOSFETs on this circuit and this circuit, it's only one half of these circuits actually running on these two transformers, and basically they're in series with these ones, which means seeing as these aren't being driven at all, it's just going to confuse the whole circuit. So the power that should be coming through here is not going to get rectified properly because it's all not, you know, half of the signal isn't even there. So if I was to move, I guess maybe 4 of these MOSFETs from this one to say this one, it should work, I guess, for testing if I can be bothered doing that. But honestly, I mean, the drive waveform looks perfect. The output doesn't look blown at all. I think I just need to replace these MOSFETs. I think really that's it. I think these have just blown up for whatever reason, maybe just overheated or old age or just cheap parts, and they just wore out. So yeah, I think it's safe to say I'll just buy 8 more FETs. I mean, they're really cheap, like I saw on the internet there, you know, 70 cents or something each. I'll just buy 8 of these, replace those, and it'll probably work, because everything else seems okay. That's it for this one. Hope that was interesting. Hopefully it will continue to be interesting, and hopefully I'll be able to fix it and make a good video out of it. Anyway, apart from that, no one else to say, so I'll see you next time.